Okay, so this one wants to know what the dimensions of the span is, right? So think of these as just vectors, okay? With your just the coordinates. All right, so the span is all the possible linear combinations of these things. Okay, so the first thing I want to do is actually look to see whether we have independence or not. Okay, remember we're just doing a linear combination there. And if you just set this up as a matrix, okay, 12, 11, 10, 9. If you just set that up as a matrix and then row reduce that sucker, now if you row reduce it, the calculator tells me we're going to get, let's see, 1, 0, negative 1, negative 2, 0, 1, 2, 3. And then the bottom two rows are zeros, which means two of these are dependent on the others, right? So we can knock those out with, and ignore those when it comes to the span. And all we have are these two vectors, then, that everything is a linear combination of. So the dimension that we're looking for is 2, because it has two basis vectors. Now, this one that you asked about, this linear operator thing, is a little bit trickier. But we're looking at the derivative stuff here, right? The second derivative and 4 times the whatever. So think about the derivatives for a polynomial. Since a linear operator, and we start off with any old polynomial, x to the n plus a n minus 1, x to the n minus 1 plus blah, 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 blah. And then if we take the derivative of that, of course, we're going to get n a n x to the n minus 1 plus n minus 1 times a n minus 1 x to the n minus 2, blah, 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 blah. So we get to 2a2x plus a1. Now, if we take the second derivative, so there's the first derivative, the second derivative then is going to be n times n minus 1 times a n x to the n minus 2 plus n minus 1 times n minus 2 n minus 1 x to the n minus 3 plus, and then 2a2. Okay. Now, so what we'll do, we'll take then the d squared minus 4d plus 1. Now all of this stuff has to equal 14x minus 2 in the end, right? That's what we're going to keep the eye on the ball here. So really all I care about are kind of the coefficients for x and the constant terms. Okay, but if we do d squared minus 4 times d plus 1, remember what we're doing is we're taking this times this polynomial. So you can think about it as having kind of like the distributive property thing. So our d squared, okay, has a whole bunch of stuff, okay, and then let me add one in here just so it makes it real clear. 2a2, so kind of in this spot here, we would have had the a3, so that would be 3a3x squared plus that stuff, right? And then down here, that would have given us 6a3x plus that. Okay, so we're going to have a whole bunch of stuff, plus the 6a3x plus 2a2 minus 4 times then the first derivative, and again I'm really only going to care, I'm going to write down the linear stuff, a whole bunch of stuff, plus a1x plus a naught, plus, and then the polynomial, because it's 1 times all of that stuff, think about it that way, okay? So we're just going to wind up with a bunch of stuff, plus a1x plus a naught. All right, so thinking about all my like terms and stuff, we're going to have lots and lots of stuff, okay? And then for my degree 1 terms, it'll be 6a3 minus 4 times a1 okay, plus and have a1 wait a minute. I wrote some stuff down wrong up here. For that first derivative, those linear terms, that was supposed to be a 2a2x plus a1. Okay. So let's see what we got. So the 6a cubed, and then 6a3 plus minus 4, 8a2. So when I distribute here, that'll be the coefficient for x, and then plus a1, and that'll be all the stuff with the coefficient for x. Okay, now all the constant terms, I have 2a2 minus 4a1, and that was an a naught, plus an a0. Now, all of that's supposed to be equal to 14x minus 2. But all of this junk that's in the beginning, okay, all of those coefficients have to be 0, okay, which tells me that an and an minus 1 all the way down until you get to a2 are always going to equal 0. Okay? Which means that this is 0, this is 0, so the coefficient for x is only a1, so that tells me a1 has to be 14. And if a1 is 14, this is 0, negative 4 times 14, let's see, that would be, what, 56. So this part tells me that negative 56 plus a naught has to equal negative 2, which means that in this case a naught is going to equal 54. So the only polynomial that has that 14x minus 2 as its image is 14x plus 54. Okay. So I skipped over kind of a lot of little details you might kind of want to write out, which I think you can do, but maybe they'll help a little bit.